Hi everyone, my name is Abdur, and like a lot of you watching this video, I love astronomy and astrophotography. I am both a visual observer and an astrophotographer, and I find that the only thing more fun than having a hobby like this is actually sharing the hobby with everybody else. So that's why I decided to make this video and this channel. So right behind me here, you can see my main telescope, that is the Celestron C11 EdgeHD, and I've been using this telescope for about a year and a half now. And despite it being an amazing telescope, in my opinion, I didn't see a lot of comprehensive reviews of this scope out there. So I decided I would do my own review of it. And in case you're wondering if this is the right telescope for you, or you're looking for a scope like this in the market, it might help you make up your mind about this telescope. So this review is entirely my own opinion. I bought this scope with my own money after saving up for a long time. So this review is not sponsored by Celestron or anybody else in any way. So my opinion on this scope, whether positive or negative, is entirely my own. So this review does apply to the other scopes in this series as well, including the C8 EdgeHD, the C9.25 EdgeHD, and the C14 EdgeHD. Since they all have a focal ratio of about f10, the only difference will be what kind of magnification or sample size you get for images. So the review applies equally to all of those ones, even though this is the only one I own from the Celestron EdgeHD series. So in this review, I will also be sharing some of the amazing pictures that I've taken with this scope, including pictures of galaxies, planets, the moon, nebulae, and all sorts of interesting objects such as the International Space Station. I also purchased a lot of the accessories for this scope over the last year and a half, and I'll be demonstrating some of them as well. So for example, although the scope normally has a focal length of 2800 millimeters and a focal ratio of f10, this right over here is the 0.7x focal reducer for the Celestron C11 EdgeHD. As you can see, that is a heavy chunk of glass. But what this does is it brings the focal ratio of the scope down from f10 to f7, so it decreases the exposure time in half. And if you are, whether you're imaging or using the scope visually, it gives you a much wider field of view, because normally the field of view of this scope is better for planets and lunar photography or visual work. But you can't get really wide fields with this, so the f7 reducer does allow you to get a wider field of view, as well as decreasing your exposure time in half, so you don't have to use really long exposures when taking images. And I'll be talking a bit more about that later. I also purchased the Hyperstar accessory. So this is the Celestron C11 EdgeHD version 3 Hyperstar accessory from Starizona. So you hook up your camera to this one, and instead of having the camera at the back, the camera goes where your secondary mirror is in front of the telescope. So instead of the focal length of the scope being 2800 millimeters or 1400 millimeters, like it is with the f7 reducer, your focal length is now 560 millimeters, but with an 11-inch scope. That is a focal ratio of f2. So basically your scope collects light really fast, and you don't have to use very long exposures at all, or even guide if you want. You can do unguided exposures of a minute or two, and just during that time you can capture a lot of data. So I'll be sharing some of the images I've taken with that as well, and then some of the other accessories that you can see on the scope right now. I have this dew heater band right on the scope, so that keeps the secondary mirror, the corrector plate, from fogging up. So that way I can image in conditions even when there is a lot of dew out there. And then the other accessories that I purchased include this dew shield over here. So the dew shield does the same thing. It reduces the amount of stray light entering the front of the scope, as well as keeps away dew for up to about half an hour, I've found. But the dew strap is necessary just because of how large the corrector plate is on this scope. And lastly, one of the other accessories that I have is the Bader click lock. So this is great for visual work if you want to use it as a visual back and attach a refractor diagonal to it. With some of the really wide field eyepieces, it can help to get the maximum clear aperture, so you're not experiencing any vignetting in the outer edges of the field of view. With really wide, like let's say, 21 millimeter 100-degree ethos eyepieces, so it could help with that. But this is not particularly necessary, and I haven't really used it that much because I actually have an external focuser that I use on the back of the scope, this guy over here. So this one comes in handy for planetary imaging. So I use this focuser for planetary imaging. That allows me to keep the object in the center of the field of view instead of having the object move a little bit, because if I use the focuser built into the scope, I do notice a little bit of mirror flop. So that's something that's common with almost all SCT telescopes and all the Celestron SCT telescopes, except for the new Celestron RASA scopes, which have a different focusing system. But it's not a big deal at all. Doesn't make too much of a difference to me, and I haven't really noticed any detrimental effects. But it is easier if you're doing planetary or lunar imaging to use an external Crayford focuser like this. So I'll be going over the pros and cons of the scope and how you can mitigate some of those or improve your experience using some of these accessories that I purchased along with the scope. And last but not least, one other accessory that I did purchase for the scope was actually the Celestron focus motor. Now this is not necessary, but if you are imaging at f2 using the Hyperstar adapter, for example, then it does become necessary. So I purchased the Celestron focus motor. This was the V2 version 2 of the focus motor. And it has worked beautifully. That way I can autofocus using my laptop as well throughout the night whenever I need to, and I don't have to be manually tweaking focus with a Batinov mask. And you can see the focus motor right over here at the back of the scope, and it's powered directly from USB. You don't need a 12-volt adapter for it, which is great, so I can just plug it directly into my laptop or my USB hub and control it completely from the computer. Let's go get the scope set up outside and see how it does. So the temperature out here right now is minus 16 degrees Celsius, which is about 3 degrees Fahrenheit for our American friends. And that's actually quite nice considering it's the Canadian winter out here. We sometimes get temperatures down to minus 40 degrees Celsius when I'm out here trying to image at night, which is minus 40 degrees Fahrenheit. So this is actually quite a nice. This review is going to be split up into two parts. The first part is going to be astroimaging or astrophotography. That's where I take pictures using the scope, and the second part will be for visual observers, anybody who wants to look at the night sky with their eyes using an eyepiece in the scope. So since I do both, I decided to do a review for both of those, although the review will mainly focus on astrophotography and how to take pictures with this scope. So here's what I've learned while imaging with this scope at f10, f7, and f2. I find that at the default setting of f10, the default focal ratio of f10, the scope is actually a bit slow for my taste for astrophotography. And what I do find also is that based on my local seeing near the mountains of Alberta over here, the seeing is never good enough. So at f10 and 2800 millimeters, I'm always a bit oversampled. So that means that the image is going to be a little bit blurry and it's going to be way too zoomed in, as a matter of speaking. So the details are not going to be sharp, and I need very, very long exposures because the camera that I'm using, the ASI 1600 mm, has 3.75 micron pixels, so I'm very, very zoomed in. I believe the actual sampling size for the technical folks out there is 0.28 arc seconds per pixel, which is very, very zoomed in, and my seeing is usually about maybe 6 times worse than that. So I'm not getting the I'm not taking full advantage of the scope at f10 based on my seeing. So unless you live, on the top of a mountain in Chile, you're likely not gonna get great results imaging at f10. And the other situation would be if you're using an old CCD camera with very, very large, 9 or 10 micron pixels. In that case, you might be well sampled. But for me personally, it was way too oversampled while taking pictures at f10, and the exposures I needed were very, very long, and it just wasn't a great experience. And also my mount, the EQ6R Pro, wasn't quite up to tracking at f10 and 2800 millimeters. So that's when I decided to use the f7 focal reducer, this guy over here, to bring the focal ratio down to f7. And at f7 I was imaging at 1400 millimeters, and for the technical folks, that's about 0.4 arc seconds per pixel with my particular camera, the ASI 1600. And it would be similar for most people's cameras. Most people might be imaging at about 0.6, 0.7 arc seconds per pixel with the popular cameras of today, like the ASI 294. But I still found that to be too oversampled for my local seeing over here at f7. And the seeing was just not good enough, and I was throwing out a lot of subs because of the poor seeing near the mountains. And if you have really, really good seeing in your area, f7 might be acceptable. If you're imaging at between 0.4 and 0.7 arc seconds per pixel, with most cameras out there, that would be pretty acceptable. And for any of the new people watching who are curious how to calculate, what your sampling size is, or whether or not the camera and the telescope you're using work well together, here's a link that I'm going to pull up on screen that you can use to figure out your optimum sampling for your scope and your camera. So if we put them in for the ASI 1600 camera and the Celestron C11 EdgeHD scope, here's what we get at f10, and here is what we get at f7. So even though it's better at f7, it's still oversampled for my seeing, and my exposures are still fairly long with my setup, and my field of view was still relatively narrow. So it still wasn't an amazing experience trying to image at f7 with this scope and this camera. So this is one of the pictures that I had taken by binning my camera 2x2, so that way it decreased my focal length by 50% effectively. Or it decreased my resolution by 50%. But as you can see, despite relatively long exposures and integration time, the image is nothing to write home about. So personally for me, that was still a little bit too slow, and I didn't have 30 hours to dedicate to one object. So that was still not the setup for me personally for astrophotography. So here's what I did next. That's when I got the Hyperstar adapter. So this Hyperstar adapter brings the focal ratio down from f10 or f7 to f2. Now we're talking. F2 is really, really fast. So for those of you who do daytime photography or regular nighttime photography with a camera and a lens, you know that if you're using a fast lens like the Canon, let's say 50mm 1.8, wide open at f 1.8, that is a very, very fast lens. You're collecting a lot of light compared to, you know, f 5.6 or f7 or f10. So using the Hyperstar adapter basically turns your telescope into a giant, 560mm f2 system, which is amazing. That's exactly what I needed, it turned out. And here are some of the pictures that I've taken with this setup. Now, you can see just how wide the field of view is with this setup. I was able to capture almost the entire Andromeda galaxy, which is absolutely massive, as you can see, compared to the size of the moon over here. But I was able to capture almost the entire galaxy using an 11-inch telescope, and that was not something I was ready for. That was absolutely amazing. And you can see just how much detail I was able to capture in that galaxy. You can see those red hydrogen alpha regions, which are large star-forming nebulae, just like our own Orion Nebula. And you can see those large blue regions along the outer edges of the image. Those are also regions with large, massive, luminous blue variable stars, so very, very large stars. And you can actually see individual stars in the Andromeda galaxy with just an 11-inch telescope and a 10-year-old camera. And that was not something I expected, but I'll make another video about trying to image individual stars in other galaxies, because that is just a fascinating topic. So stay tuned for that one, and if you want to be notified as soon as I post that video, please hit the subscribe button and like this video, and then you'll be notified as soon as I post my next video. Now, from what I said about imaging at f2 using the Hyperstar, it seems like that is the perfect solution for anybody who wants to get a scope like this. But what are the downsides, and why isn't everybody imaging at f2? Well, besides the fact that it is a bit expensive, the Hyperstar adapter alone is about, I think, $800 from Starizona right now. There are some downsides. So the primary downside of imaging with the Hyperstar adapter is that you have to collimate it. You can see these screws along the outer edge here. And collimating at f2 is very, very difficult. Now, I spent almost a year trying to get perfect stars along the outer edges with my camera, and it turned out my camera sensor was a tiny bit tilted as well, which made it an almost impossible task, because I was trying to adjust both the tilt of the camera sensor and the tilt of the Hyperstar adapter itself, and making sure that my secondary was actually centered in the telescope itself. And just these variables interacting with each other made it very, very hard to get perfect collimation at Hyperstar. I had used the tutorials online that I could find, and I just couldn't get perfect collimation, and I had almost given up. I was one night away from giving up when I had a new idea, and it all ended up working out. I had seen a tutorial online from somebody about how to collimate your camera sensor, and I modified that approach and created this adapter that you can see over here, and this allowed me to collimate the sensor of my camera, or adjust the tilt of the sensor of my camera, so it was perfectly perpendicular to the optical axis of my telescope. And then after that, I centered my secondary on my C11 EdgeHD. Not something I recommend for most people. In most cases, it is going to come perfectly centered from the factory. And then I adjusted my Hyperstar, and as you can see in this image over here, I finally got perfect stars along the outer edges of my images, which was that was an amazing feeling after struggling with it for a year and being so close to giving up. So I'm glad that worked out. And the other downside to imaging with the Hyperstar at f2 is that you normally have to manually change the filters. You have to use a filter slider just provided by Starizona or any of the other companies, and you manually switch the filters. So if you're imaging with a monochrome camera, like I am with my ASI 1600 monochrome, and you can use filters such as the luminance, red, green, blue, hydrogen alpha, oxygen. So you just manually swap the filters, and that means you have to be up there all night manually changing filters whenever needed, or you need to dedicate an entire night to each filter, which I definitely did not have the time for. So I ended up coming up with a method that worked for me, and that might have been part of why it was so hard for me to collimate. But I'm actually using a ZWO electronic filter wheel, so I have all my filters inside this filter wheel. And I ended up making 3D printing. Actually, I ended up 3D printing a little plastic piece that goes around it, so that the sharp edges of the electronic filter wheel, they're not going to give me diffraction spikes. And as you can see in my images, I don't get any diffraction spikes really, or they're barely noticeable even in very, very long exposures. So that's how I solved that problem. So I can automate the setup entirely, and I don't have to manually change filters, which is one of the downsides of this kind of a setup. And one other minor issue when you're imaging using the Hyperstar is that you can't use an external focuser. You have to use the built-in focuser in the Celestron C11 EdgeHD. And with most SCTs, there is a little bit of mirror flop, so that's something you just have to be cognizant of. I haven't noticed that to be a major problem, but it is a bit of a problem for some people. So as your scope slews across the sky to different parts, your mirror changes its position slightly due to gravity, and then that changes your focus in your image a little bit. So one of the corners of the image might go out of focus as you slew to a different part of the sky. So since you can't use an external focuser, that can sometimes be a bit of a challenge with the Hyperstar, and you can't really use your mirror locks if you're using an autofocuser, like the Celestron or the ZWO external focuser. I mean, the one that attaches right to the scope instead of using a motorized Crayford focuser. But that was not really a big issue for me. So one alternative to the Celestron C11 EdgeHD or any of the other scopes in its lineup that does solve the problem of the mirror flopping a little bit when you're imaging using Hyperstar is the Celestron RASA system. So that's basically like imaging with a Hyperstar scope like this, except that you can only put the camera at the front. It doesn't have the option to use an eyepiece with it or to put a camera at the back. So with the 11H, for example, you would have a 560mm focal length scope all the time. So it's not quite as versatile as the EdgeHD lineup, where you can image at f10, f7 or f2 and use it for visual as well. For the RASA scopes, you can only use them at their designated focal length around f2 and only for imaging. You can't use them for visual. So they do solve the mirror flop issue. They use a new redesigned focus mechanism, so your mirror is much more stable and it doesn't really tilt as you focus. So if you're only going to be using this scope for imaging and nothing else, and you are not going to be doing planetary or lunar imaging, it's only deep sky imaging, and you want a wide field of view, the Celestron RASA scopes are an alternative. And actually quite a few of my friends have gotten the 8-inch RASA, so they can image at f2 all the time, which is great if you don't want to spend a lot of time imaging or the weather in your location isn't very suitable for imaging all the time. But personally for me, I like the versatility of being able to do planetary imaging and visual with this scope as well. So personally, for my situation, I would not trade it for a RASA. But if you're primarily just imaging at f2 and want a good fast system, and actually the RASA also has an overall wider imaging circle. So if you're imaging with a full frame chip, the RASA 11 might be a better alternative to using a Hyperstar like this one. This is the version 3 of the Hyperstar, so it's suitable for up to APS-C sensors, which is the one you'd find in most regular cameras. But the version 3 of the Hyperstar from Starizona is not quite suitable for full frame sensors, and I wouldn't use it with a full frame sensor anyway. And the version 4, which is the newer version than mine, that one can be used with full frame sensors, although I'm not sure if you get perfect correction to the edges. But my ASI 1600 and a lot of the consumer grade Astro cameras use a micro four thirds sensor that includes the ASI 294 that's very, very popular these days. And the version 3 of the Hyperstar has no problem with this size of sensor or even APS-C sensors once you get everything collimated perfectly. And in a future video, I will explain how to collimate the Hyperstar perfectly so you too can get perfect stars along the edges like this. So let's talk about visual observing with this scope. Although I had said that this was my primary scope, it's not quite my primary visual scope. My primary visual scope is actually this beauty over here. This is a 16-inch f5 Dobsonian telescope with a premium mirror made by a local master optician by the name of Barry Arnold. And this scope was actually built by someone I know who had built it maybe 30 years ago, and I had purchased it secondhand from them. So this is what I mainly use for visual observing, but the Celestron C11 has done an amazing job at visual observing as well. So here's my experience with it. At f10, at its default configuration, this scope has a focal length of 2,800 millimeters, which is actually quite long. So even with the widest field eyepieces, in my case, that is a 20 millimeter, 100 degree eyepiece, you can't see a lot of the wider objects. So if you're trying to see the entire Andromeda galaxy, for example, or you're looking at the Beehive or the Pleiades, you can't quite fit them in the field of view. So in that case, the f7 focal reducer comes in. And with the f7 focal reducer, you get a significantly wider field of view. So I'm just going to pull it up in Stellarium, and here is what the Pleiades looks like. That's the Seven Sisters. Here's what it looks like at f10, 2,800 millimeters without a focal reducer. And here's what it looks like visually in a 100 degree, 20 millimeter eyepiece using the f7 focal reducer. So you can see that the field of view increases considerably when you're using the f7 focal reducer. And the scope, in terms of optical quality, it is a joy to use. Stars are sharp across the entire field of view, so you don't see, comma or any aberrations in the outer edges of the field of view, like I would in most other scopes, or even my large Dobsonian that I use for visual. The stars are pinpoint and perfect all the way to the edges, even with my widest field eyepieces. And the view is very, very sharp. And when I'm looking at the double cluster, for example, the field of view that I get using my f7 focal reducer is actually the same field of view that I get with my 16-inch f5 Dobsonian. The view of the Dobsonian is going to be a bit brighter because it does have a much larger mirror. However, I found that the view is really clean in the C11 EdgeHD along the outer parts of the view, so I don't get any of those seagull shaped stars in the outer part of the view. And since my Dobsonian telescope is primarily for visual use and not an imaging scope, I can't use a coma corrector in that scope, so I may have to eventually move the mirror up a little bit to be able to use my coma corrector in that scope. But the Celestron C11 EdgeHD, it has perfect stars all the way to the edge at f10 and at f7. So overall, I really like it. Observing some of the objects like the double cluster, Andromeda, M13, the Hercules cluster, the Orion Nebula, all of these objects look absolutely amazing, and you can see a ton of detail all across the field of view. So overall, I would recommend this scope for visual observing as well, just because of how nice the stars are. But the field of view is going to be narrower than, say, an 8-inch Dobsonian, or if you're using a refractor, so a small refractor. So the field of view will be a bit narrower. Where the scope really excels, though, in terms of visual observing, is planetary and lunar work. So because of the really long focal length of 2,800 millimeters at f10, you can get really high magnifications on the moon and the planets using pretty much, any eyepiece. With a 10 millimeter eyepiece at f10, you're going to be getting 280 times magnification. So you don't need to use eyepieces with really small focal lengths, because those can be a bit hard to come by sometimes. So when your seeing is really good, you can get phenomenal views of the planets and the moon. I have done some planetary imaging with this scope as well in the past, but I'm looking forward to being able to do a lot more of that this coming year when Jupiter and Saturn are going to be much higher in the sky from my location. So overall, what do I think of this scope? Well, I think the scope is a jack of all trades, and it's actually pretty good at almost all of them. It's a great scope for imaging, especially if you're using the Hyperstar adapter to get a wider field of view and much shorter exposures. It's absolutely amazing for that. I mean, I have managed to image objects down to magnitude 20. I've captured asteroids that were magnitude 18 or 19, one of which I captured recently that was not on any databases. I've captured individual stars in other galaxies, so that's unimaginable for me if I was not imaging at f2. So it's a great scope for imaging, especially if you're using the Hyperstar adapter at f2. And for visual work as well, it's a really nice scope, very, very sharp pinpoint stars. But again, that depends on the objects you're trying to view. So not quite suitable for large galaxies like the Andromeda, but great for globular clusters and smaller objects. And it's also a really, really nice scope for viewing the planets and the moon. So while it depends on what your needs are, I do think this is a great jack of all trades. It does everything, and that's what I wanted. I wanted to downsize my collection of scopes, so I didn't want to have one scope for every different kind of imaging that I wanted to do. So this scope does it all. It does great at planetary imaging, does great at lunar imaging. It's great for wide field imaging at f2 with the Hyperstar adapter, and it's a great scope overall for visual. Although these days I do plan to use my giant Dob for visual, so the scope will mainly be relegated to imaging at Hyperstar at f2, and I normally like to just keep it that way so I don't have to take the camera off and on all the time.